So they save money on shipping. We save money on the product because they don't have to spend as much for shipping. We get more concentrated things. We then add water to it to get it to the concentration of what we need. Now, the company is what tells us usually how much water to use. And that's the key to it, because otherwise we wouldn't know, right? And you wouldn't want to sit there and taste test your soapy water for your clothing. So usually they add a cup, or they add the tap for it is actually the measuring cup, right? So that's how they tell us. Scientists don't have that. Scientists, I don't know if I have any, but let me check real quick. So if they take a look, we get bottles like this all the time. This bottle was probably filled with an acid of some type in it. That acid would be, if it's HCl, we would get the concentration of 12 molar. Why do you think this is probably one of those questions for a student of the month? Why do you think we would get 12 molar only for HCl? Why wouldn't we just buy higher concentrated HCl?
Isn't it just so strong that it's too dangerous to hold it like that?
12 molar is dangerous as well. It's very dangerous. But that's the highest they sell it to us in. Good thinking though, Coco. Anybody else want to try? Why is 12 molar the highest concentration of HCl that you could buy? Bum bum bum. Hudson, what did you think?
Is it like the most cost effective for the company?
Most cost effective for the company. You guys are so mad you got messed up by the shipping one yesterday, huh? Nope, it's not about the company. Well, maybe it is saturated, right? Well, that's the problem. Maybe they can't get it to super saturated, so the best they can do is just sell you the saturated as they could make it, right? So if we take a look, I said HCl, right? So we know that this room is about 20 degrees Celsius. So there is a maximum that this HCl per 100 grams of water can hold at 20 degrees Celsius. There's a maximum, right? So they give me that maximum. They give me 12 molar. Well, if I want to take 12 molar HCl and I want to make one, let's just do 2 for fun, 2 molar HCl, and let's say I want to make 100 milliliters of it, I need the cap. The company that sells me the HCl, they don't sit there and sell me the caps, or I just cannot take a capful and make whatever I want. There's no markings on it or anything. So I actually have to figure out how many milliliters I'm going to use of the 12 molar. I got to find the cap. I got to mathematically find that cap. And this is the formula for that. If I want 100 milliliters of 2 molar, how much of the 12 molar do I need? Well, 200 divided by 12.
It's about 16.6666.
16.67 milliliters, or get significant digits right. Let's say this is 12.0 and 2.00. 100 exactly. I need 16.7 milliliters of the 12 molar HCl to make 100 milliliters of 2 molar HCl. So that means I take 16.7 milliliters of the concentrated stuff, and I add enough water to make that up to 100 milliliters. And I have this new, less concentrated HCl now. That's how we make things from an already made stock solution. Before, we were taking solid particles and we were putting them in water and mixing them up. A lot of times chemists already have a bunch of solutions that are of high concentration. If they need to run trials or mix something to make something, they will dilute those high concentrated stock solutions and use what they want. So that's what she's doing. She wants to prepare 500 milliliters of a 6 molar aqueous NH3 solution. She's got 15. How should she prepare it? But she needs to know how big her starting measuring cup is, right? So again, I call this formula M1V1 equals M2V2. They call it the the molarity of the stock solution times the volume of the stock solution equals the molarity of the dilution times the volume of the dilution. I don't care which way you do it. Most of the time with this, you'll be solving for V1. So I want to divide to both sides by M1. So here is the volume 2. Here is the molarity. And here is the molarity that we have. Six times 500 divided by 15.
The answer is 200.
So 200. That's our cap. We need to take 200 of this big solution, this concentrated solution, and we add enough water, 300 milliliters of water to make it 500 milliliters of the new solution. What are we doing? We're adding solvent to decrease the concentration of that stock solution. Questions? Of the stock solution, and we're adding enough water to end up with 500 milliliters. So keep in mind, we don't sit there and say, take 200 and add 300. We always use the words, we add enough water to reach our final volume. Because remember, 50 plus 50 does not necessarily equal 100. If I take 50 milliliters of alcohol and I mix it with 50 milliliters of water, I'm not going to get 100 milliliters. The alcohol can find places between the water. We get less than 100 milliliters. That's why we always say add enough water to get up to our final volume needed. One of the hardest things we do in here is make salt water. It's usually what we actually write the lab write-up on. Still haven't figured out whether I'm going to do that this year or not, because it's hard for you guys at home to write a lab write-up for a laboratory that people in here did. Like, I mean, a multiple page lab write-up. Questions about that? Here's more detailed instruction. They show you how the way I did it. They also show you here that you can do this through multiple steps. Again, I don't suggest that. Use the formula. Take 2.5 minutes and try this one with our chemists from examples 2 and 3. What are you finding in this one? The cap, right? Does everybody understand what I'm saying when I say the cap? I should bring one of those in. Like when you buy laundry detergent that's in liquid form, the cap of it is a measuring device. I mean, it tells you how much to use for a small load of laundry all the way up to a large load of laundry. Otherwise, you would Mia this and just sit there and go, glug, 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 that's enough, right? It looks good, looks good. if you don't use the cap, and it may over it, so it won't all rinse out the soap, right? If you use too much. But that's what the chemist doesn't have the luxury of, because they have to make so many different chemicals of different concentrations. They always have to figure out how much of the stock solution to make. There's no set cap on any of our chemicals. And this is something where you can't just go, ah, that looks like a good enough amount of HCl in there. That'll do. We can't do that. Yeah. Like even I think cooking, like people use a capful of vinegar instead of like 2 tablespoons. Like it's weird. Like I think a vinegar cap probably has an actual measurement, like teaspoon or something like that, you know? Well, let's read it. It's going to be a reading comprehension thing. We want to prepare. So that right there tells us that these both are what? Ones or twos? Twos. In reality, as long as you got the 2 of the same together, it would not matter which side of the equation they were on, you'd still be able to solve it. But this prepare tells us that that is 500 milliliters of what we want to make. And this connecting word of tells us that this 30.0 molar is with it. And we're going to set that equal to 18 molar, and we want to solve for the volume of that initial. 3 times 500 divided by 18.
It's about 83.3.
How many significant digits? 2. It does. That has 3, but this only has 2 and this only has 2. You always go with the lowest number, right? 8.3 what? Well, molar and molar cancel out, so we're left with milliliters. Questions on that? Kind of easy stuff. At that point, you should be able to do 7, 8, 9, and 10 for homework. Let me take a look at what next week is so I can show you guys as well. Da, da, da. You know how water works. So Monday, you're going to learn how salt works. Look at that. I don't even have that set up. Did I make it? Anybody know if there's an assignment called How Stuff Works? Water or salt? Salt. How do I do this? Link, course link. Assignments. Come on now.
I have a question about the exercise 3 problem.
Yeah.
So since the answer is 8.3 milliliters, does that mean that she uses 8.3 milliliters of H2SO4 and then the rest is water?
You got it. Yep.
Okay.
That's exactly it.
Wait, I'm kind of confused now. I thought it was 83 milliliters, not 8.
I'm sorry, not 8.3, but 83. Yep. I think she just said 8.3 on accident. It's 80.
Oh, yeah.
Yeah. She used 83 milliliters of the stock solution of this 18 molar, and then adds enough water to dilute it to 500. Yeah, sorry.
Oh, okay.
I wasn't even thinking about the number. I was just thinking of the concept she was telling me that was correct. So Monday, how stuff works, salt. He doesn't say water a bunch, so it's a little bit better. Tuesday, we're going to review this for Wednesday's group and individual tests. Let's not be gross on this. Don't cheat, but your group, first you work out 5 problems with your group, and then you work out 4 problems on your own. Does that make sense? So then Thursday, basically Tuesday and Thursday, this is probably the hardest math we do second semester. If you thought that thermochemistry was a hard math part, you're going to probably find difficulty with this again. This is Basically, we're doing all the different types of concentrations that you can find, and then how to go from one to the other to the other. So yay. And that takes 2 days at least. And then on Thursday, we'll also discuss the laboratory, which means it will be you guys next week for Friday. Basically, what I'm going to do is I'm going to give them a solution, and they've got to tell me the molarity of it, the percent by mass of it, and the molality of it, which we've not learned what molality is yet, but Tuesday and Thursday we'll do that. There's molarity, there's molality, and there's normality. Molality. Percent by mass, also we learned Tuesday and Thursday, but you take the mass of the mass of the solute divided by the total mass of the solution. So that's probably the easiest one, because if I give them the solution and they find the mass of the solution, all they have to do is find out what's mass of what's dissolved in it. How do you guys think they're going to turn it from a solution back into a solute? If you had salt water, how would you find the amount of salt in there?
Couldn't you evaporate the liquid and then you get all the solid out of it?
Yep. You could evaporate the liquid and then you would have just the salt left over. The problem with this is that the salt's going to be stuck to your glassware. So in order to find the mass of the salt, you would have to first know the mass of the glassware empty. And I think we had a few labs or concepts that we did that with last semester, where we knew the mass of like a whey boat or something like that. But yeah, so that's going to be key. And this laboratory on Thursday, when we put you with your groups, you guys will have to make kind of the procedure for it. And that's going to take us into next week, whenever the real frustration begins, whenever I say, okay, go back there and make me a 2.5 molar solution of something, right? And then you're just sitting there like 2.5 molar, what does that mean? And then you have the brain, which could definitely do it on paper. The problem is can the brain translate whenever the fingers have to be involved? It gets kind of crazy. One of those things that have almost driven students to tears. Like imagine this, if you had to make your own contact solution. Like all it is salt and water, right? The problem is the concentration has to be perfect. Otherwise, when you put that on your contact and on your eye, what's going to happen? It's going to burn, right? It's going to burn your eyes out. It's going to hurt. But that's basically it. We take for granted too much that everybody always tells us to use a capful of this or 3 teaspoons of that. Chemistry and chemists, we actually figure that stuff out. Now, just to give you an idea, I don't know, but did we show the Burple thing last year? When I was a kid, I usually show it now. So when I was a kid, my mom did not fall for these, but when I was a kid, they had what's called Saturday morning cartoons. And President Ronald Reagan actually made it okay. Oh yeah, right. I thought, like when I looked at you, I was sitting there thinking, like, I think I'm pretty sure that she's seen this. But President Ronald Reagan made it okay to advertise to children, which is bad. But that's how you guys had all the play dolls, like the G.I. Joe figures and all that was basically in the 80s. They advertised that. They shoved so much advertisement at kids, it was insane. So this is, oops, I just messed it all up. This was the commercial where, you know, you're watching the Saturday morning cartoons. Destro's plane just went down because G.I. Joe shot it out of the air or whatever. And then this commercial comes on, and then you yell at your parents for about 20 minutes how much you need Burple. So here is a Burple. You guys can't see it, can you? I'm sorry, I've got a different setup than I normally do because I was having some issues with technology. So I'm going to fix this real quick for the people that are here. And look at these sweet, sweet 80s jam pants and jam hats.
Twist and stretch, add water to the Shake yourself silly. It's totally here. Drink big purple, baby purple too. One's for the game, the other's for you. Fruit purple, juice drink concentrate with natural flavors and vitamin C.
Oh, did they even get to see that? Did you guys even get to see that at home, or am I big dummy? You didn't get to see it? Oh, we'll have to watch it again. I'll do the dance
Twist and stretch, add water to the lip. Shake yourself silly. It's totally here. Drink big purple, baby purple too. One's for the game, the other's for you. Fruit purple, juice drink concentrate with natural flavors and vitamin C.
So, you guys know the meme, we have McDonald's at home? You guys know that? Yeah, right? So basically, my mom is like, we got purple at home. And she just basically like made us Kool-Aid, right? She was not having any of it. One thing that the purple does is it's its own container. So when you expand it, it's already got the sugar and the Kool-Aid mix in there. And all you do is add the water to it up to their level. So again, they've sat there and figured out any of the measuring. Kool-Aid has already figured out the measuring as well. It's 1 cup for 2 quarts. This equation that we're using and the math that we're doing is what allows chemists to make any concentration that they need. And that's the difference. In our everyday life, everybody's figured out all of the different things that we need to add. Chemists have to figure it out themselves. And as I was telling you the other day, this is why, biology teachers, if you not do this ever and enough, and then all of a sudden it comes up in your life that you need to make a certain concentration of something, this is what you do. This is the math behind it. I think that's all I've got for today. If you guys have any questions, by all means, stay on. Otherwise, you guys are good to leave. This was my favorite. If you want to stick around, I've got a favorite commercial of a kid, and me and my brother would sit there and run around the house singing this like idiots. Like, it was crazy.
Yama yama.
We've got the food, good taste. We've got the food and new island cereal.
Rhode Island has sweet apple bits on every island, and sweet cherry, orange, and lemon taste. So please, King Yama Yama. Oh, how does it taste, Almighty King?
Yama yama.
Rhode Island's brand cereal.
So we would sit there and walk around yelling a yama yama, which today is probably, like a little bit, like a micro aggression, right? Crazy. All right, guys, that's all I got. Have a great day.